position vectors of points P, Q, and R are vector OP is -3, 6. Vector OQ is 2, 1. Vector OR is 4, -1. So that P, Q, and R are collinear. We can draw a sketch. We can draw a sketch like this one here to represent this line here. Then we can refer to vectors P, Q, vectors PQ, PQ, and vector PR, vector PR, PR. Now we can say that vector PQ is equal to vector, we can take our origin to be somewhere here. Origin O can be somewhere here. O. Origin O is here. So now we can say that vector PQ is given by vector OQ minus vector OP and vector PR here is given by vector PQ is given by vector OQ minus vector OP, and vector PR is given by vector OR minus vector OP. Now we can find vector PQ. We can find vector PQ. PQ will be 2, 1 minus -3, 6. PQ will be 2, 1 minus -3 and 6, and PQ is here. PQ, this is our PQ. PQ. P is 3, -3, 6. That is P here. And Q is 2, 1, 2, 1. So now this is giving us a 5, -5. 5, -5. Then vector PR. Vector PR is 4, -1 minus -3 and 6. That is PR OR. OR is 4, -1. OR is 4, -1. OP is -3, 6. OP is -3, 6. And this is giving us 7, -7. 7, -7. So we have to note that points are collinear if they lie on the same straight line. So to prove that vector PQ and PR are collinear, how can we prove that vector P, Q and P are collinear? How can we prove that? We can say that K, that is the scalar, 5, or we can say K times vector PQ is equal to PR, where K is a scalar. We want to prove that vector PQ and PR are collinear. They lie on a straight line. So we can substitute. We can say that K vector PQ is a 5, -5. 5, -5 is equal to PR. PR is 7, -7. This is PR here, PR. And this is going to give us a 5K, -5K is equal to 7, 7. 7, -7. And from here we can say that 5K is equal to 7. 5K is equal to 7, and -5K here is equal to -7 here. We can divide here by 5, we can divide here by 5. K is equal to 7 over 5, and we can also divide here by 5, we divide by 5. -K is equal to -7 over 5. This implies that K is equal to 7 over 5. So now our scalar is 7 over 5. Our scalar is 7 over 5. You can say that therefore the scalar K is equal to 7 over 5. This implies that 7 over 5, 5 minus 5 is equal to 7 minus 7, and this means that vector PQ is parallel to vector PR, and it also means that It also means that point P is a common point. Point P is a common point. Therefore, we can say that vectors PQ and PR have a common point P. Vectors are, you can say that vectors are P, Q, and P, PR have a common point P. Hence, we have proved that P, Q, and R are collinear. They lie on a straight line. Thank you for watching.